Assalamu alaikum. All right. So we will continue the same project, which is project one. And we have done some work like this, okay? Where some things are remaining, such as RCC stair, and then, of course, the Chajja carpet, plaster, and whitewash work, okay? Let me just open the same project. It is just tour here. Okay, let's just determine, okay? Let's say if we have plaster work, okay, we will take the stair at the end, no problem. Okay, so let's just see we have the plaster work, and the plaster work that can be internal and external as well. So let's just focus on the external first. Okay, we have external, you can see, and we will just take the parameter of the wall, and then we will multiply that with the height of the wall. Even you can do that with the long wall, short wall method. Okay, if you have long wall, short wall, you can just apply that method as well, no problem. But over there, we may have some things such as, let's say, if we take the long wall, which is just this external one, okay, there can be actually some deduction then for this place, okay, because we don't have plaster over here, okay, on both sides of the wall. So it's better to have the parameters and then multiply the parameters with the height. So there, that can be then very easy, okay? So let's see. The first thing, let me just draw a line, and so we can see it, okay, better. Let's say if we have a red line, and I'm gonna have just a, you have to actually, you may have this drawing in a hard form, okay, then you have to just add the sides like 25, then this side, okay, which is 32, then you have to add this one, and which is like, and this one as well, okay. So these can be added, but for the sake of easiness, I'm going to draw a polyline so you guys can see it. Okay, the plaster can be on this surface. You can see the red line. Okay, then on the same surface up to this point, then, okay, and then of course up to this point, and so on up to this point and till the end. So this is external plaster. Okay, we might have plaster on this external surface. So let's say, I'm gonna say external plaster, okay? And let me just remove this, the serial 10, so we can complete the serial 8. So in plaster, let's say external plaster, okay? Now external plaster, I'll take that one and the length, okay? So you have to just count this parameter, okay? I'm gonna just use AutoCAD so I can do it very quickly without wasting much time. You can see the length is 116 and 6 inches, okay? So 116 feet and 6 inches means 0.5. Now, what should be the width? There is no width for that. The technician just ignore, you can say, because the plaster work is taken in terms of area, and we have already discussed these things before. So the height can be the wall height. If you see, over here we have the wall height, which is 10 feet and 3 inches. Okay, so that is 10.25. Okay, now we have the quantity like equal. We will multiply the height with the length, and then of course, and this length is actually, you can say, the parameter, okay, and then the number. You can see this is the area which is in SFT. Very simple, okay. Now, in remarks, you can even include like this thing. You can say this is, let's say, the external parameter, okay. This is number one. Now we will have internal plaster. Internal plaster. And internal plaster, we have different rooms, you can say. Okay, let me just open this thing. Okay, so as you can see, we have two rooms and their size is different. The lounge size is different, okay. And even we have plaster on the staircase and the kitchen size is different, okay. And over here we may have plaster, okay, on this column. But this is RCC column. We don't need plaster over here. There can be only whitewash or maybe the tile work, okay. However, you can check these things in the specifications, okay. The bill of quantities that is just asked for. You have to just calculate the things according to that, okay. No problem. All right. Now next, as you can see, we have to determine the area, the parameter. Okay, let's say if I can draw a line okay, from this point till this. Okay, this can be actually the internal plaster. Okay, you can see the red line. Okay, this can be the internal plaster. So as you can see, we have to determine its parameter, and the parameter, as you can see, we're here in the properties, that is 45 feet and 9 inches. Okay, we have just added all the sides. Now, as you can see, these two rooms have the same dimensions. It means we will multiply this with 2. Okay, so as you can see in the internal plaster, I'll say bedroom, and they are 2 in number, and the length is 45 feet and 6 inches. Okay, let's confirm it again. That is 9 inches, sorry. Okay, so 0.75 can be added. And then, of course, the height is just the same for each plaster work. Okay, so we will drag the formula, and as you can see, I'm going to remove the 0, and this is going to be in SFT as well. So this is actually for the bedrooms. Now, for the bath, we will take the same thing. Okay, you can just draw a polyline, and I'm not going to delete the old one, so we can just say that that is already done. Okay, so as you can see, this is 24 feet and 5 inches. So the length is like 24 feet and 5 inches, means approximately 0.4 something. Okay, 435 or maybe 0.45, and that is only one n number, and the length is just the same as I mean the height is just the same. This is the parameter. Okay, the quantity can be applied, and this is going to be an SFT as well. Now next we have the kitchen. So let's say if we have the kitchen, I'm gonna just apply the polyline from this point over here. This can be the length. Okay, this way. And this is actually something, we don't have wall over here, and the wall is the same thing up to this point. We'll ignore the thickness of the, you can say, slab for the landing, no problem, okay? And up to this point, it can be, you can say, okay? And even, let me just include the lounge, okay, up to this point, okay? You have to add the parameters, okay? And these can be just determined from the drawing, no problem, okay? I'm just gonna include all the lounge so we can have that thing in short time. Okay, okay, the plaster can be up to this point. You can see this red line. Okay, this is the plaster parameter, and let's say that is 96 feet and 7 inches. Okay, 96 feet and 7 inches is almost 0.59 something. Okay, or maybe 0.6. Okay, no problem. I'm taking approximate value. In number, that is 1, and it means the kitchen plus lounge, and the height is just the same, of course, and we have the quantity and then the parameter. Yeah, I mean the unit. Okay, that's done. We have actually the veranda is taken. Okay, in the external plaster, no problem. Okay, what we have remaining is actually the stair. Okay, and the stair, of course, I can even just there is thread and then the rises. Okay, so we have to plaster both. Okay, now for the threads, I can just take this rectangular portion. So as you can see, we have already covered those all threads. Okay, and this rectangle is just 34 feet and 6 inches in length. Okay, so you can say stair, and stair, I'm gonna say the threads. Okay, and they are different in number. I'm not gonna include, so I'm gonna say 1 because we have already taken all of them in one rectangle. Okay, you can see that this is just a one rectangle. Now for the stair, we have the rise, you can say, and that can be 1 in number because I'm gonna take the whole at the same time. Okay, the rise for 1, that is 6 inches, you can say. So 6 inches is the height of 1, and it's, of course, if you see it is 3 feet wide. Okay, the stair is just 3 feet wide. So the total height is 10 feet in 3 inches. Okay, you can see that from the section. So we will take this height, and then of course the width, okay, which is 6 feet. Okay, because 3 feet plus 3 feet for the other side. So it means the length is now 6 feet, and I'll take the height is the same thing, because this is gonna cover all the rises. We are not doing each separately. That's gonna take much time, okay? Like counting the number of steps, etc. So this is the best way to do it. What's remaining now is actually in the drawing, they have not provided headroom, balcony, etc. Okay, so we are not discussing all those things. The things which we should discuss is actually the deduction, you can say. So let's just cover deduction. And in the deduction, we have different doors, windows, etc. Okay, so deduction for doors, from windows, and ventilators. Now, in deduction, if you see, we have already calculated deduction for the brickwork, so I'm gonna copy that. However, something will be little bit changed. Okay, as you can see, we have detection for doors, window, and this is for the brickwork. Okay, let me just copy these things, and then we will have some measurements. However, one another thing which is really important, and we have just forgot that the slab plaster work. Okay, slab is just forgotten. Okay, so we have slab. Now, slab can be one in number. However, we're gonna take actually these red areas. Okay, these are actually the areas of slab. You can see that. It's very simple. Okay. Again, we will just copy those things, and as you can see, these are actually the top areas. And for the veranda, even we will include this area because this is slab, right? However, externally, we have this slab, you can say this is treasure, but we will just ignore the thickness of the walls. We are not subtracting the thickness of the walls, okay? That's just included, no problem. That can be a small video. However, if you're gonna calculate each thing very like 99%, then you have to take the top area of each layer, like these red squares, you can say, are rectangles, are these red parameters you can see, okay? So these are the parameters of the slab. Like if you see, if you need to determine the slab plaster for the same bedroom, okay, you have to take the same area, which is actually this area, okay? That is just 130 square feet. But I think calculating these things take much time. So it's better to take the external slab, okay, and see its area, it's 956, okay? So I'm gonna take that one, very simple, 956. And let me just include that, okay? And that's just an SFT. Because the slab, okay, you can just see the parameter, okay? One side of the slab that is 27.6 and another side that is approximately 34 and 9, okay? So it means the bed that is 34 feet and 9 inches, and of course the length, of course, 27 and 6, so 27.5. In number, that's gonna be 1. Now in quantity, we have actually the formula, which is the width times the length times the number. That's almost that video, 955.6, okay? So very simple. It's good to take the okay, AutoCAD is just helping for the quantity surveyor, okay? All right, now the detection for doors, window, etc. I'm gonna copy those things. Okay, where is it? It's over here without the units. Okay, copy them and paste them over here. Because these things are just known, but the things which are just we have to remove is actually the thickness of the wall, okay? And we will take actually both sides. That's why we're gonna multiply these things with 2, because this is the surface area now of one side. Okay, we have 2 sides plaster work, so that's why we're gonna take 2 over here again, right? Very simple. Like if we see, we have window 1, okay, and the size is 5 by 5. Now 5 by 5 can be internal or external plaster. We have to subtract both sides plaster for the same window, okay? So that's mean I have to multiply this area with 2. However, window 1, that is 5 in number. It means we should have another column, but placing another column is just time wastage. We should just multiply the whole thing with 2. That's gonna be very simple then. Okay, so it means I'm gonna have 2 over here, okay, for 2 sides. Now this is the total area now for the deduction. Okay, we don't have deduction if there is, however, headroom over here for the slabs, which is not just asked, okay, in the same project. So, and there is no drawing available for that. So you can then just subtract that whole for the stair, okay? We have the total deduction. So let's say we're gonna select one extra cell. As you can see, this is going to be in SFT. This is the total deduction. That means now we can calculate the net plaster work, okay? So we can say the net plaster work. What should be net plaster work? We will subtract the deduction from the total plaster work, okay? Now total plaster work, I'm gonna insert another thing over here, and let's say the total plaster work over here, okay? Total plaster work, and we will add actually them, okay? Now the plaster just started from here, from this point, we're gonna add them all, okay? Up to this point, and then just click this summation, okay? So this is the total plaster work, you can see it. This is going to be an SFT. Now we will actually subtract that, okay? So in net means we will subtract this deduction from the total. Total is that one, and minus the deduction, which is this one, okay? So this is now the plaster work, SFT. The chacha, or you can say the parapet, that is just remaining over here, okay? So let's just check that. And we're gonna take actually the same thing, which is, you can say, the perimeter of the slab, okay? You can see this slab. So the perimeter can be taken like in the properties, if you see the length, that is 124 feet, okay? So 124 can be taken for the chacha's length. That's 120, and that's already taken, you can see. So in quantity, I can say 124.5. That is in RFT, or running feet. Now let's just calculate whitewash for the same project, and that's gonna be number 9. Okay, I'm gonna say whitewash, and whitewash can be external or internal, and I'm gonna say is per the item number 8. Okay, so I'm gonna say is per item number 8, because the place we have plastered, that can be just whitewashed. Okay, so it means the whitewashing is 4,299.91, and that's going to be an SFT. However, the column can be included over here, okay? We can just add the column, because column can be whitewashed, and that is 2 by 2, and of course the height is just 11, okay? So that's 2 by 2, very simple, and you can just include that maybe above or below that, so you can have the total, okay? Like maybe you can say column whitewash, that is 1n number, and that is 12 by 12 inches. Height is just 11, so the quantity can be 11 times 1 times 1, 1, that means 11, okay? We can add the total by the summation, so we can have the total over here in SFT. That means total whitewash. All right, what next? We have something that is remaining, just a minute, is actually the RCC work for the staircase. Now, as you can see, we have this staircase, okay? I'm just gonna copy this, make sure you have just the plan and then the section, okay? We have this simple one, which is not that completed yet, okay? Because we have not that much detailing, but it does not matter because it is just a small project and we can use AutoCAD over here, okay? So let's say we have this thing, okay, where we may have different elements such as the landing, the waist, and then these steps, okay? So we'll be just determining 3 things over here, okay? Let's just jump over here. You can say we have staircase. Where is it? I'm gonna insert 3 rows just for the landing, for the waist, and then for the steps, okay? So I'll say steps, landing, and then lastly, of course, the waist, okay? Now in number, there should be 1, 1, and 1. And of course we have just a minute, we have RCC stair, the landing, the waist, and then of course the steps, okay? And there should be 1 again. Now as you can see, the first thing which I'm going to calculate is the landing, okay? Let's just jump into the AutoCAD. As you can see, the landing that can be of course 6 feet, which is actually you can see this is 6 feet wide staircase, and of course landing is going to be 3, I guess, because this is just a narrow stair. Okay, so this is 3 by 6, and now the thickness, that is I think 6 inches. Okay, that's good. So we will have landing, and that's the length is, let's say, 3, its width is 6, and then of course its thickness, that is 0.5 inches. I mean feet, okay, because it is 6 inches, which is of course 0.5 feet. Now we'll apply the same formula to the same cell over here, and this is of course 9, and that must be CFT. Okay, then we have the waist, but before waist, let me just calculate the steps. Now steps can be different in numbers, that's not one. Okay, we will count them, you can see it. Okay, like maybe I'm gonna ignore this one because it is, you can say, a rectangular step. I can even calculate this separately, but does not matter. Okay, here it may have some foundation as well. Okay, let's say we have foundation of 6 inches, and then of course like this. Okay, something like this. So the steps, we will just count them. Okay, and you can even count them from the section and then from the 2D plan. Okay, and that's of course 1 2 3 4 5 6 7 8, and then 9 10 20. So we have actually 20 steps. We're here, the steps are 20, not only one. The size, the rise is just 6 inches and straight is just 12 inches. It means the step is just triangular, and remember the area of a triangle, we'll just determine its cross-sectional area, and then we will multiply it with the length of the step, you can say, which is of course 3. Okay, so here this is taken as 11 inches. However, it means it is some kind of mistake over here. Okay, it should be 12 inches, but does not matter. In the section we have 11, so let's rename this one. Okay, it means it is 6 by 11 inches step. 11 inches can be converted into feet, very simple, and you can just divide that by 12 to convert it. Okay, which is almost 0.91 something. Okay, so we'll have just a formula, you can say. Okay, for the steps, these two columns can be cross-sectional area. Remember the length is just 3 feet, and the cross-sectional area can be of course these two cells. Okay, now it is a right angle triangle, so we can take 1/2 base times its perpendicular. Okay, so you can say equal, and 1/2, that is just something like 0.5. Very simple. Okay, we'll multiply this with the width or the perpendicular, which is of course 6 inches, the perpendicular, and you can say 0.5 feet, and we will multiply this with the third, which is of course 11 inches, or maybe 0.91 feet. This is the area, and now just apply the same formula. You can say this thing, the height times the cross-sectional area times the number of steps. This is going to be the quantity, and which is of course 13 CFT. Now I'm going to insert another thing. You can say the stairs foundation, or you can say base. I'm going to say base, and there is of course only one over here, and in the section you can see we have this base. Okay, which is of course if I'm not wrong, that is 1 feet and 0.4 inches, almost 1 feet. We'll take 1 feet. Okay, does not matter, and the height is just 1. It means it's 1 by 1. Okay, so the base is just 1 by 1, and its length must be 3, because the stair is just 3 feet wide. Okay, you can see it is total 6, but one flight's width, it is just of course 3 feet. You can see it. So the quantity can be we will just drag that formula over here. You can see that must be 3, right? CFT. One thing that is remaining is of course just the waist. Okay, the waist of the staircase. And remember, as you can see in the same thing, this is going to be the waist. You can see this. Okay, the slab, you can say below the steps. We'll actually have to determine the length of the waist, and we have already learned that using the Pythagoras theorem. Okay, like if you have the height, maybe this is the height. Okay, and then maybe we have the base. Okay, so when we have the height and then the base, then of course we can determine the Pythagoras theorem. I mean by the Pythagoras theorem its length. Okay, but I'll not use Pythagoras theorem because we have already discussed those things. Okay, in the previous few videos. So I'll just use AutoCAD over here, and as you can see, this is 8 feet and 3.5 inches. And for the second flight, you can say I'm gonna have the waist, which is of course 10 feet and 6 inches almost. Okay, I can even take the length is total, so 18 feet plus 9 inches, it means 18.75. okay, this is going to be the length of the landing. Very simple. Sorry, the length of the waist. Okay, so 18.75 is the length of the waist. Then of course we have its weight, which is of course the one flight breadth or weight, you can say, and there's of course 3, and the thickness must be of course 3 inches, which is of course 0.25. okay, let's just confirm if it's 3 inches or not. Very simple. Okay, I'll just annotate it and let's confirm it. It's of course 3. Okay, very simple. We'll just drag the formula so we can have the quantity, and that must be in CFT. Now as you can see, we have now calculated the overall you can say the total RCC work. We'll just select one extra cell and then click this summation, which is of course 562. Now we'll have some deduction. Okay, and then we have already calculated the deduction, if you remember from the previous video. Okay, and this is the deduction for the stairs hole. If you see, we have this hole, okay, in the same drawing, like maybe this hole. Okay, so we'll just subtract that thing, does not matter. So we have the net RCC work, like maybe you can say the total RCC work, which is this thing, and we will subtract the deduction, which is 33. Okay, press enter. We have 529.03 something. Okay, CFT is the net RCC work. Okay, so these are the materials which were asked by the client. Okay, for the same project, just a simple project having 2 bedrooms. And let's just now determine the abstract of cost. Okay, from the MRS, we'll use MRS, and I guess it's enough for today, and we will of course just end the session. End the project tomorrow. Okay, and I guess tomorrow is going to be the last day for the same course. Okay, so we'll see you tomorrow inshallah, and we will just complete this project by determining the abstract of cost from the MRS. So see you tomorrow inshallah. Allah Hafiz.